Welcome back, friends, students. Now we shall continue the next problem. Write the minors and cofactors of a determinant of third order. Delta is equals to 1, 0, 4, 3, 5, minus 1, 0, 1, 2. You know very well about the definition of minor and cofactor in earlier. And also you know how to find the minor of an element A11, A12, A21, A22 like this second order determinant in the previous example. But now this is the third order determinant to find the minors and cofactors of each elements. Minor of the element 1, which is A11 position, and minor can be denoted by always M11, means according to definition of the minor, you leave this row, this column, which gives the result of determinant order 2, 5, minus 1, 1, 2. Hence, minor of 1, that is equals to M11 equals to 5 minus 1, 1, 2. By cross multiplying 10 minus of minus 1 plus 1, which gives 11 is the value of this determinant. Minor of the element value becomes 11. Similarly, minor of the element 0, which is in the A12 position, its minor can be denoted by M12. That's equals to, you leave this row and this column, remaining elements are 3, minus 1, 0, 2. 3, minus 1, 0, 2. Multiply principal diagonal elements minus secondary diagonal elements, which gives the result of 6. Am I right here? Then minor of the element 4 is equals to, which is in the A13th position, hence that is minor is denoted by M13, that's equals to, leave this row, this column, 3, 5, 0, 1, that is equals to, cross multiply, we'll get the value 3 minus 0, which is equals to 3. Similarly, the second row begins with the minor of the element 3, that is in the M21 position, A21 position, hence its minor can be denoted by M21. That means you leave second row, first column, second row, first column, which gives 0, 4, 1, 2 as a determinant. 0, 4, 1, 2. Multiply 2 into 0, minus 4, which gives the minus 4. And the next is minor of the next element, that is 5. Minor of the A22 is 5, hence it is denoted by M22, that's equals to, you leave second row, this column, then which gives 1, 4, 0, 2. The result is, that's equals to 2. Then minor of A23, the element minus 1 is equals to A23 position. It is in the A23 position, hence that's equals to minor of that A23 is given by M23, that's equals to, you leave this row, this column, which gives the second order determinant 1, 0, 0, 1. 1, 0, 0, 1. Cross multiply, you will get the value, that's equals to 1. Come to the next row, last row, third row. The minor of element 0 is in the A31 position, hence its minor is denoted by M31, that's equals to, you leave this row, this column, which gives 0, 4, 5, minus 1, 0, 4, 5, minus 1, that's equals to cross multiply 0 minus 20, that's equals to minus 20, which gives the result minus 20. And next element, minor of A32, that means 1. Minor of the element 1 is equals to, it is in the A32 position, hence that's equals to denoted by M32, that's equals to, you leave this row, this column, which gives 1 4 3 minus 1, 1 4 3 minus 1. Am I right here? That's equals to, cross multiply, you will get 13. Then the minor of the element last, that is in the A33 position, that is 2. Minor of the element 2 is in the A33 position, that's equals to M33, that is equals to 1035. That's equals to, cross multiply 5 minus 0, that's equals to 5. Hence, all these are the minors of all the elements. The next one is cofactor of the elements. Similarly, we can find the cofactor of each element by using capital A. Cofactor of the first element is 1, hence it is always denoted by AL1 because 1 lies in the AL1 position, hence AL1 is equals to minus 1 to the power of ith row, jth column, hence first row, first columns into the minor of ML1, minor of AL1. That's equals to 1 into the element AL1 minor is, the element AL1 minor is L1, hence that's equals to 1. Cofactor of the element, second element is 0, A12 position, it is denoted by capital A12, that's equals to minus 1 to the power of 1 plus 2 because A12 is in the first row, second element means second column, hence first row, second column, minus 1 to the power of 3, that's equals to minus 1. Its minor is 6 because already we found the minor is 6, hence it is multiplied by the minus 1 into 6, 6, minus 6. The third one, cofactor of the third element, that is A13, that is 4, that's equals to, cofactor is denoted by capital A13, that's equals to minus 1 to the power of first row, third column, because the element 4 belongs to the third column of first row, hence minus 1 to the power of 1 plus 3 into minor of 13th element, minor of 13th element. Already we found earlier 3, hence minus 1 to the power 4 means plus 1 into 3, that's equals to 3. That's equals to 3. Am I right here? Continue. Then cofactor of the element 3 means A21 position. In the question you observe 3 is lies in the second row, first column, hence A21 position. The cofactor of element 3 is equals to A21, then minus 1 to the power of second row, first column. This is 1. It is 1. Hence 2 plus 1 becomes minus 1 to the power of 3 into minor of A21 already we found, that's equals to minus 4. Minus 4. Hence minus 1 into Q, minus 1 into 3, minus 1 into minus 4, which is equals to plus 4. cofactor of the element 5. That is in the A22 position. Hence A22 equals to minus 1 to the power of 2 plus 2 into M22, because M22 is the minor of A22 element. Then 5 lies in the second row, second column, hence 2 plus 2, which gives the value of 2. Similarly, the minor of cofactor of the element 0, which lies in the A31 position, its cofactor is denoted by capital A31. That's equals to minus 1 to the power of third row, first column, third row, first column, which gives the 8 minus 1 to the power of 4 into M31. Then minor of the A31 element is minus 20. 1 into minus 20 gives minus 20. Similarly, cofactor of the element 1, which is in the A32 position, that is denoted by cofactor is denoted by A32 minus 1 into the third row, second column, into the a minor of A32 element is minus 13. Hence minus 1 to the power of 5 equals to minus 1 into minus 13, which gives plus 13. Lastly, the minor cofactor of the element A33 is 2. Hence, cofactor of the element 2 is A33, because 2 lies in the A33 position. Hence, A33 is the cofactor, capital A33 is the cofactor of element 2. That's equals to minus 1 to the power of 3 plus 3. Why we should write here 3 plus 3? Because A33 means 2 element in the question. 2 element lies in the third row, third column, hence third row, third column. Therefore, minus 1 to the power of 6 always into, that's equals to 1. Its minor is 5. Multiply 1 into 5 gives plus 5. Hence, all these are the minors and cofactor of the elements of the third order determinant. Am I right here? You have understood the second order determinant, minors and cofactors, third order determinants, minors and cofactors. But now the next type is the different problem based on the same minors and cofactors, but only one thing, using the cofactors, how we shall find the elements of certain rows or certain columns. Often you will get this type of questions in your examination carrying 2 marks. What is the next question? Number 3, example 3. Using cofactors of the elements of second row only, evaluate delta is equals to 5, 3, 8, 2, 0, 1, 1, 2, 3. This is the question carrying 2 marks. Using cofactors of the elements of second row only, evaluate delta is equals to. What is, first you understand the question, what is his required answer? What I should do? First I have to find the cofactor only. Need not to find the minors. He requires only cofactors of the second row. What are the elements belonging to the second row? 2, 0, 1. Only we have to find cofactor of 2, cofactor of 0, cofactor of 1 from the given determinant delta. Second row only. So for that purpose, before going to this, we should keep it in our mind the positions of the corresponding signs of the elements A11, A12, A13, A21, A22, A23, A31, A32, A33. Hence, to cofactor of 2 is minus into directly minus into 3, 8, 2, 3. Directly you can find. Here minus, you leave this row, this column and this row, this column. What are the remaining elements? 3, 8, 2, 3, which is according to the significant signs by the rule to find the cofactors, then that's equals to minus into 3 3s are 9 minus 8 2s are 16 minus into minus 7, minus of minus equals to plus 7. This is another one method to find the cofactor of the elements. Do you know? But to solve this type of problems by using such a method, you should keep it in your mind, this type of the significant symbols by using the rule. So, cofactor of the element 0, because according to the rule, the sign becomes first, you should write here plus. Here plus this is. Plus into 0 element. 0 element lies in the second row, second column. You leave second row, second column. Write down the remaining elements 5, 8, 1, 3, 5, 8, 1, 3. Cross multiply, evaluate this determinant value which gives 7. Then cofactor of the element 1, which is lies in the second row, third column, second row, third column. Then according to the sign, minus is here, minus. So minus into, you leave third row, third column, second row, third column. Then remaining elements are 5, 3, 1, 2, 5, 3, 1, 2, cross multiply, 5 2s are 10, minus 3, minus of 10 minus 3, which gives 10 minus 3 means 7, minus into 7 equals to minus 7. Hence, these are the cofactors 7, 7, minus 7 respectively. But he requires evaluate delta. How do you find the value of delta? Delta is equals to the cofactor of first element 2 into the cofactor value of corresponding element plus 0 into the cofactor value plus 1 into the cofactor value, which gives 7 2s are 14 plus 0 minus 7 1s are 7, which gives 7. This is the third example using cofactors of elements of the second row only, and also evaluate the value of delta. The delta value becomes 7. Cofactors are these 3. Am I right here? Any difficulty? Please ask. Okay. Shall I proceed? Then, using the cofactors of the elements of third column, evaluate delta. In the previous question, he requires using the cofactors of the elements of second row, but here he requires using the cofactors of the elements of third column. Am I right here? Third column, and evaluate delta value. See here, cofactor of third column and evaluate delta value. Here I have shown the arrow mark, third column, first column, second column, third column. Am I right here? Then first row, second row, third row. The first element of third column is YZ here. Alphabetical elements means alphabetical values are given here. Then cofactor of YZ is equals to, according to the formula, the value of the cofactors corresponding signs by the rule YZ is equals to, you leave this row, this column, this row, this column, only thing the remaining elements are 1 Y, 1 Z. Then cross multiply, Z minus Y is the result. Cofactor of YZ is Z minus Y. Similarly, second element and belonging to the third column, second row of the second element belonging to the third column of the second row, the cofactor of Zx is equals to, according to the formula sign, that is minus into, then you leave this row, this column, which gives 1x, 1z. That's equals to z minus x. Minus of z minus x equals to x minus z here. Minus into minus plus x, then minus into z minus z, x minus z here. And similarly, then cofactor of the third element of third column, that is xy, that's equals to, you leave this row, this column, that means 1x, 1y are the remaining elements, 1x, 1y are the remaining elements, cross multiply, y minus x, y, this is x, y minus x, hence this is the cofactor of third element of the third column. First element is z minus y. Cofactor of second element is x minus z. Third element is y minus z. These are the cofactors of corresponding elements. But how do you find the value of delta? Delta is equals to value of, means first we write yz into its cofactor z minus y, plus then zx into its cofactor x minus z, then xy into its cofactor y minus z, xy into bracket y minus z, then yz into z minus y, keep as it is, plus zx into x, zx square, zx into x, zx square, minus, plus into minus, minus, zx into z, z square x, plus xy into y, xy square, xy square, plus into minus, minus, xy into x, x square y, x square y. That's equals to yz into z minus y, yz into z minus y, plus x square, take x square as a common, here I have mentioned the marks like this, eliminated zx square, x square y, because here one common factor we'll get it, that is x square. Take x square as common from these two variables, then zx square, here x square, minus x square y, here x square into z minus y, x square into z minus y. Then here I have made the underlined minus z square x plus xy square. Yes, what is the common factor here in these two terms? Minus x is the common. Minus take minus x. X is the common, only x is the common, into bracket z square minus y square, because here I have taken minus x, then here the z square, and also this becomes minus y square. I have taken here minus x as a common, so z square minus y square. Take common z minus y from all these three terms. Here z minus y, here z minus y, here z minus y. Take common from all the three terms. A linear equation, three terms, I have taken z minus y common. One of the guy will arise a question, sir, here z square minus y square, but how do you take the z minus y as a common? A guy answers for this, another one guy answer for this question by keen observing this term z square minus y square by applying the a minus b into a plus b identity of the factorization from 6th standard or 7th standard. I recall the memory by taking identity of these two, z minus y into z plus y, which gives z square minus y square. So for this term, apply a plus b into a minus b factorization of the identities, then we'll get here z minus y as a common. Then remaining term is z plus y. Listen here in the next position. Take z minus y as a common, then what are the remaining terms? In the bracket yz plus x square minus zx minus xy. Here you take z minus y as a common, z minus y as a common. What is there? Remaining first term is yz. Am I right there? Then plus z minus y common, x square is there. Here yz plus x square. Am I right here? Then here z minus y as a common, you take here minus x into z plus y is the next term. You understand here. Here z minus y you take common, then minus x into z plus y is in this bracket. So multiply by the x. Z plus y means minus x into z minus zx, then minus x into y minus xy. Hence z minus y as a common factor into bracket yz plus x square minus zx minus xy. Z minus y into bracket yz minus xy, one bracket, plus x square minus zx. Then again take y as a common factor, z minus x. Here minus x take as a common, minus x take as a common. Here minus x into plus z, because here I have taken minus x as a common, which is the result. This is the value of delta for the fourth question using cofactors of the elements of third column. Evaluate delta value. This here he has used the algebraic variables. In this earlier problem he used the numerals. So hence I have solved here 4 problems and also minor and cofactor definitions. Everything you have studied in this video class. Then in the next class I have given some homeworks based on the minors and cofactors. Then we shall begin with the next topic in next video class. Have a good day. Goodbye. Good luck.